Multipath is another one of those RF properties that probably needs a bit more attention. Multipath is just reflections. We talked about reflections in the RF properties, so what makes this more important to talk about? Multipath is really more of a discussion of reflected signals between two Wi-Fi devices. If we have a client device here, we can make this a phone, and we have an access point here, and we're of course indoors, we're in some sort of room here. Multipath is just multiple reflections. You're going to get a signal, so we're going to say the signal is coming from the client device, but that signal is not a beam of signal. It is omnidirectional. It actually is sent really almost in all directions from this device. So multipath is hundreds, if not thousands, of different reflected signals. We're showing very simply just a few of them for the sake of an easier discussion here. That you'll see these multiple reflections that get bounced around, and the receiving device, this goes the other direction too, by the way, so don't just think it's this way. It also goes from any transmitter to any receiver. In this particular case, so what's the big deal? We have the original signal, which did not encounter any reflections. We have some others that did get reflected. So what's the problem? The problem goes back to phase. If, again, you skipped ahead here, we got to go back and learn about phase. There is a delay on, we'll call this signal 1 and signal 3. Signal 1 and 3 took longer to get there because they didn't take the direct path. So what happens is they are actually a little bit out of phase. If the original signal looked like this, so we'll say this is signal number 2, signal number 1 would actually be a little bit behind it. So it would actually get there. Let's see if I can think this through here. It would actually get there and look something maybe like this. Oops. Did not do that right. Here, if you look, the peak is just a little bit off. It's just a little bit shifted. Remember, all a phase change is just a time relationship between two signals. At least in this case, we've seen that there's a time difference between signal 2 and 1, and 3 and 2 would be, let's just say, identical because we'll say the delay is perfect. When a receiver gets two signals like this, it actually doesn't see two signals. It actually sees one of the combination of the two. If I were to try to draw some combination, which was really going to put my artistic skills to the test here, it's going to be some kind of odd version of this. Now, this odd version of this can still be interpreted, but it may not be as good. It's like being in a room that has a lot of echo. If I'm trying to talk to you or you're trying to talk to me in a cave, I'm going to get, that's a great example of multipath, I'm going to get your real signal, but I'm getting all these reflections, and luckily, I have a couple of ears and I have some brain power that can at least try to decipher them as best as possible. But if you're going to talk as fast as an auctioneer, I'm not going to understand you because I just can't process the reflections that fast. So multipath is a thing that happens because of something called delay spread. The delay between signal 1 and 2 and or 2 and 3, that is called a delay spread, and that's just the difference in time. Now, what can that difference in time make happen? Well, if 1 and 3 are the same, so if we were to erase this, if we say 1 and 3 are the same because they encountered the same reflection, it's perfectly symmetrical, then we could actually get extra signal. Two signals that are in phase together and received together actually create gain. That can be called upfade. So they create some of this gain. Now, what happens if they're really far apart? What if this delay was really long and the phase was really out of whack? Here's a really extreme example. Maybe this one, looked like this. Okay? Maybe it's really crazy looking like that. You can get downfade. You can get a significant loss in signal. And the worst possible scenario would be a complete opposite signal. which I almost drew here perfectly, and these perfectly cancel each other out. That would be called 180 degrees out of phase, and that can actually cause the signal to be received as a null. If there was a way you can do this with sound, actually, if you ever heard of noise-canceling headphones, they actually transmit negative sound, the inverse of the airplane engines. If you have children, you may have tried to invent the mute button for them that would transmit the opposite of what they are. I have been working on this for quite some time. It has not quite worked out yet. Not to say I'm not going to succeed there eventually. So multipath is just multiple signals. How that gets processed is cool. Old school way to process this, 802.11a, b, and g. We haven't gotten to standards yet, but just know that this is, original Wi-Fi all the way through the standard that was introduced in 2003, which is 11G. They used two antennas on the access point to do what was called diversity. Basically what it would do is that it would have two antennas, and it would actually look at the signal, the reflected and the original signals, and then choose the right antenna, and it would try to help cancel out those reflections. In old school Wi-Fi, reflections were horrible. They were actually very, very bad for a network. Today, it's the opposite. Today, we went from diversity as being the way to receive signals and try to figure out what to do with them. Today, we're at something called MIMO, multiple input, multiple output. This is a whole topic in itself, probably multiple videos actually. But just know that with multipath, MIMO is great. MIMO loves multipath. In fact, if you don't have multipath, MIMO doesn't actually perform as well. It was really an interesting change from 11G to 11N when us old school guys had to relearn this. And when we did site surveys and we did Wi-Fi network design, we had to start realizing that reflections and getting this multipath were good. It even changed where we put access points. Instead of installing them in just the center of the room, we may purposely install them elsewhere. So multipath, multiple signal reflections arriving at the receiver. Again, keep in mind this can go either direction. How those signals look to the receiver, in phase, out of phase, causing up fade, down fade, or even possibly nulling the signal. That was originally compatible with diversity. Nowadays, we use that multipath with something called MIMO.